Morning, students, and the today's class is approach roads, formation of the approach roads, transportation, and backfilling. Uh, the formation of the approach roads, the factors influencing the formation of the approach roads, and the size of the approach road, the shape of the approach road, the gradient of the approach road, different details are there, and how the approach roads are formed, how the approach roads are developed, and the OC transportation. The OC transportation, actually different phase of the mining is there, where the transportation is the major essential the phase of the open cast mining. The transportation is done in different phases. At the phase on the approach road, on the haul roads, and from the mine site to the CSP, and from the mine site to the dumping yard. Different modes of transportation is used, and what are the different types of transportation, and what are the different factors which are affecting the transportation, we discuss here. And the backfilling and land reclamation. We discuss how the backfilling is done, what is meant by the backfilling, what are the different materials which is used for the backfilling, and like the different other factors are there in the backfilling. And so what is meant by land reclamation, what are the different the material which is used in the land reclamation, and we will discuss now. And before that, the formation of the approach road and the factors depending the formation of the approach road. The approach road is nothing but it is the connecting roadway. It is the connecting roadway to the main roadway and to the mine site. Actually, the mineral may be lying below the 50 meters, and the 50 meters is the rock waste, and that is called overburden. After removal of the overburden, the mineral, the coal is exposed, and the coal is removed. So while excavating the overburden and the coal, the overburden is converted into different benches, vertical benches. So all the area is converted into different benches, and the benches are excavated. The benches are excavated by using drilling and blasting. The OB benches are excavated. In the similar fashion, the coal benches are also excavated. So again, suppose 50 meters OB rock face is lying, and below that the coal is lying. The 50 meters and 30 meters, total 80 meters. The vertical, the OB benches and the coal benches both are removed in the form of the benches. The benches are formed, benches are developed, and the benches are blasted, and it is removed. So, and the approach road which connects, suppose a first vertical bench is there, so it connects from the main roadway to the first vertical bench. Again, when we enter into the second bench, again the approach road is developed, and which connects the main roadway and this one, the second vertical bench. Similarly, all the benches wide in the area is connected to the main roadway. In a similar fashion, the coal benches are also there, and while excavating the coal benches also, the approach road is very much necessary for the transportation, where the dumpers are plying, where the shovels are there. The shovels transfer the material onto the dumpers, it is there. So the shovels are plying, the shovels are moving, and the dumpers are moving, the dumpers are running. So for that the approach road is required. So what is required? Actually, For every vertical bench, the approach road is connected. So it is the access. It is the access to reach the mine point from the main roadway. The main roadway is on the surface. From the main roadway, so a connection is necessary. A roadway is necessary, and the particular roadway is called the approach road. So the approach road, which is used for the transporting the material, the transporting the men and material. The men are the miners are there. The miners moving from surface to mine area, bottom of the mine, and going outside after the work is over. They have to be out. So for going, the particular approach road is used. So they may be coming by the trippers, they may be coming by the jeeps, the executives may be coming by the jeeps. So whatever it is, the roadway is very necessary. So the approach road which is used for the transporting the men and material. So the workers and the executives which are coming from the surface to the bottom, the last the last vertical bench. So they are coming, they have to use the approach road, they have to use the haul road. So the haul road which is used for the transporting of the men. In the similar fashion, the OB material, which is dumped in the dumping yard. So that what the dumpers will do. Actually, the drilling is done, the blasting is done, so the bench is blasted out, a lot of muck is created. So the created muck pile has to be removed. So the shovels are there, hydraulic excavators are there, and front end loaders are there, and the rope shovels are there, which come onto the surface, which are come onto the face of the open cast mining. There the shovels lift up the OB rods onto the dumpers, and the dumpers from the point to move away from the face point to the surface, or where the dumping yard is situated. Up to the dumping yard, the mud pipe, the rock waste is transported. It is there. So for the transportation, the approach, the haul road, which is very much required. So the haul road, the approach road is very necessary for plying operation, for running of the dumpers, for running of the road loaders, for running of the graders, for running of the scrappers, for running of the different coal drills and OB drills and the shovels. So the approach roads are very important roadway, and without that, the mine cannot be run. And the mine cannot be run, and the excavation is very tough. The excavation of the material is very tough. So the approach road, what we can say, maybe the haul road, and that must be made, and a certain gradient is used, and the maintenance of the approach road is very important. The maintenance of the approach road is very important, and all everything every approach road is maintained, and with this we transport the men and the material in efficient manner. So the approach road and the formation of the approach road is very much important, and the maintenance of the approach road is also very important. So this is about the approach road, the why the approach road is very necessary. In the very similar fashion, what are the different factors? And we will see the maintenance of the approach later on. And first, before that, the formation of the approach road, the formation of the shape of the approach road and the size of the approach road depends upon the machinery, depends upon the mechanism we use there, and different factors which influence different factors, different parameters which influence the size of the approach road and the shape of the approach road, the gradient of the approach road, and the way and the features of the approach road is affected, is influenced. So we listed some of the factors here, and we will discuss each and everything. And first one, the surface topography. Suppose surface topography is very undulating, and all the undulations must be clear. And actually, before that, from that point, From that point, we will do the mining. We will do the mining. Suppose if the surface is very much undulating, so the dumpers, and the road rollers, the different ocean machinery, road rollers, road graders, the scrappers, cannot negotiate with the curves, cannot negotiate with the ups and downs. So all the undulating ground must be removed. All the which are small hills are there, small hillocks are there, all are removed. All the ground must be before laying the approach road, the ground must be level. Leveling of the ground is important. Otherwise, the approach road can be. And the shape of the mine generally, areas, 10 acres of land may be excavated by the open cast mine, 50 acres land may be excavated by the open cast mine. So the area, generally the area is the shape not should be irregular. Suppose generally the shape may be the vertical, the shape may be rectangular, or the shape may be this one square, or the shape may be hexagon, octagon, like that the shape may be. Generally, the shape it is generally the shape of the circular and rectangular shapes are used. And circular shape as the rectangular and square shapes are used. When the shape is regular, the formation of the approach road is uh, the formation of the approach road is very good, and a systematic approach road is developed. We can develop systematic approach road. It is there. And length of the mine along the strike direction. Actually, the mine is the mineral is there. The mineral is formed. While formation of mineral, generally it has certain features are there. The strike direction is there. Dip is there. Dip is there. Actually, the angle of the mineral makes an angle to the horizontal plane is called the dip. So it is right angle to the strike direction. So the mineral bed is having the strike is having the dip also. So different features are there. So a lot of actually a length of mineral is there. A length of mineral is there. The length of mineral is formed while formation, and the length of the mineral generally we call it a strike. What is that? We call it a strike. Strike is there. So if the length of the mineral is if the approach is developed along the strike, then a systematic and a good a well-maintained approach route can be this thing, because the mineral is formed, the mineral is along the strike direction, not against the strike direction. So wherever the mineral is, our aim is to reach the mineral, the road which must connect the mineral of the body. So from the surface and from the bottom of the side, all along it the mineral is there. So the roadway which must connect from the surface to the bottom of side. So along the strike direction, this one, the approach is developed. The strike direction is very important. This one, and the system of waste disposal. Actually, mineral handling and waste disposal. As general open cast mine is there, and OB, the overlapping the strata is called rock waste, that is called overburden, which is removed and dumped somewhere else. Suppose OC mine is it is spreaded the 50 acres of land, 50 acres of land where OB is spread. So after removal of the overburden, it is dumped somewhere else, maybe the 5 kilometers away from the mining site, because while the total mineral is excavated, while backfilling, while land reclaiming, the removed waste rock again is used for backfilling. Say the main mineral rock which is removed, again we use for the backfilling. So that must be just nearer to the dumping yard of the overburden material, just nearer to the mine site. So when the mechanization, when the lot of machinery is used, so the maybe because so a lot of earth is removed, lot of rock waste is removed. So heavy rock waste is removed, heavy earth is removed, so that the 5 kilometers away, maybe 3 to 5 kilometers away, uh, 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 5 kilo, maybe 2 to 3 kilometers away, the dumping yard is situated, and the dumpers carry away the OB material upon to the this one the dumping yard, and where it dumps over there. So the waste disposal is important. So wide mechanism is used, and heavy machinery we use, and the shape of the approach road, the size of the approach road, because where suppose a 35 tons dumper we use here, so the size of the approach road is very simple, very small also. So when you use 35 tons, 85 tons, 105 tons, 135 tons, 185 tons, 235 tons. So these are various capacities of the dumpers we use there. So these capacities, suppose 235 tons dumper when we use on the open cast mine. So the size of the approach, it looks, it is a gigantic structure, a huge structure is there, gigantic structure is there, and the gigantic structure cannot run on a small approach, otherwise it skids away, it falls over the ground, so the accident may happen. So the approach road, the size of the approach road must be very big. So heavy mechanization we use, when we use heavy mechanization, then the rock disposal is suppose the 200 meters rock waste has to be removed, and below the 200 meters or 300 meters rock face has to be removed, and where lot of OB is created, lot of OB is formed, and the lot of OB has to be lifted away and thrown onto the dumping area. So the heavy machinery, heavy capacity machinery, heavy capacity dumpers we use them. And sometimes if the soil, if the rock face is very soft in nature, then we use the drag line, and we use the drag lines also. So the drag lines which are used for lifting the OB material, it is also there. It is there. So system of waste disposal shapes the size of the approach road, the size of the approach road, or otherwise hall road, or else we can call it the hall road. It is there, and or else gradient. It is there. Suppose generally the dumpers are the heavy dumpers, 235 tons dumper, 185 tons dumpers we use there, and 235 tons, one single dumper carry 235 tons. 235 tons dumper means a huge amount of coal is carried away. The huge amount of coal, suppose if the gradient is suppose 1 in 4, 1 in 5, 1 in 6 is there, so the dumper cannot climb up in such a huge gradient. So the gradient must be negotiable, maybe 1 in 10 or 1 in 10. Generally the gradient shall be kept 1 in 10, 1 in 11, 1 in 7. So very less gradient approach roads are used. But suppose when you use 35 tons, even the gradient can be little higher, maybe 1 in 8, 1 in 7 gradients when you use 35 tons dumpers there. Suppose when you use 235 tons dumpers there, the gradient must be very less, and that is less than 1 in 10, less than 1 in 11, 1 in 12, 1 in 13, 1 in 4. So more the less gradients means 1 in 10 gradients means is almost a level ground. What we can say, a level ground is a little gradient is there. So in the little gradient, the machinery can use very efficiently. The machinery can be used very efficiently. It is there. Otherwise, so the system of waste disposal. So this one, the Hall's gradient. If the gradient is very high, a little machinery is used. Very high means not 1 in 5, not 1 in 6, not 1 in 4. These are not at all used in this one. So more than 1 in 8, 1 in 9, those the gradients are used. But in heavy mechanization, heavy machinery we use there, and then the gradients must be very less than 1 in 10. That is, lesser gradients means 1 in 10, 1 in 11, 1 in 12, like that gradient we use it. So Halley's gradient means this is the approach gradient, where suppose the dumps are used for the transporting. Here the conveyor is there, and the conveyor is laid out along the approach road, and it must be having a certain gradient. So in a high gradient is there, the high gradient material cannot be transferred. Why? Because it falls due to the specific gravity it is there. So even whatever maybe the conveyor is used for transporting the material, or the dumpers are used for transporting the material, whatever is it, the gradient must be very negotiable, must not be very high. So not be very high, more than the gradient shall not be more than 1:8. Why? Because so the transportation becomes very complex and complicated. So this is not even heavy mechanism we use there. So the gradient must be less than 1 in 10, like that we use it. So this is the Halley's gradient. And depth of the working, depth of the support generally, and in the older times, the surface coverage is the 50 meters, and generally we prefer the open cast mining, the 50 meters of rock crust is removed, then exposed coal is removed. Then so when it goes deeper, the 50 meters, 100 meters, 150 meters, like that, up to 300 meters, the OC is possible. The 300 meters rock crust is removed, and the exposed coal is removed. So the 300 meters rock waste is removed is the toughest job. Why? Because with the open cast mine, actually, suppose more than 200 meters, generally we prefer underground mining, where with the use of the inclines, with the use of by laying the shafts, we reach the mineral there. By laying the underground mining, we prefer that. But nowadays, when the technology is increased, when the evolution of technology is there, when high mechanization is available, when high mechanization is used in the open cast mine, and we are reaching even up to the 300 meters by the open cast mining, and that 300 meters OB, the rock waste is removed, and after that coal is removed, the coal is excavated. So 300 meters going by 300 meters, the heavy, huge rock waste is created. Huge rock waste is formed. So while blasting, for 300 meters is there. When the vertical bench is 10 meters, and like that, 30 vertical benches are developed. 30 by 2. So all 30 vertical benches are spread over the 50 acres of the land. It is there. So all the vertical benches are the blasted, and the muck is on the muck pile is found, and the muck pile is removed by the shovels, and the shovels transfer the material from the face point to the face palm onto the dumpers. The dumpers carry away the material from the side point to the dumping yard. So these are the system of this one. When depth of the working, so more than 50 meters, the huge rock waste is created. For the clearance of the huge rock waste, more capacity the conveyors are required. More capacity dumpers are required. 35 tons dumper may not be suitable, and 85 tons, 105 tons, when it goes on increasing. Suppose if it's 300 meters and 235 tons capacity dumpers are required to transport the dump waste, the rock waste, from the mine site to the dumping site. So when the depth of the working is increasing, and the machinery size, the capacity of the machinery size is also increasing. When the capacity of the machinery size, when we use 235 tons dumper, and it has gigantic structure, and a huge structure is there. A huge structure, the machine cannot run on small approach road, cannot run on small haul roads. So the haul roads must be very much wide, and with a less gradient is there, and high maintenance must be there. So gradient must be very less, and the width of the haul road must be very wide. Why? Because admits so for going the dumpers are there, the coming dumpers are there, to and fro the dumpers are used, and suppose the haul roads must be generally it must be more than nearly, I think what we can do, the 10 times width of the dumper we use the hall. When high machinery, when the 285 tons dumper we use there, 235 tons or 285 tons dumper we use there, and then automatically the width of the haul road must be very much 10 times the width. So the width of the dumper is very much more, very bigger. So depth of the working is incurred, huge rock face is formed, and the mechanization, the transporting machinery, the transport dumpers generally we use 235 tons, 285 tons dumper we use. The width of the 235 tons, 285 tons dumper is very big, and the width of the haul road must be 10 times this one, because a lot of and the clearance must be there, lot of clearance must be, it is otherwise uh, the dumpers skid away and fall on the ground, it is there. So this one. And the production generally OB removal, when suppose OB removal is there is one point, in similar fashion, and many patches of coal is available, the coal is available is plenty. Suppose a 30 meters thickness of a coal is there and converted into three phases. Likewise, different patches of coal is available. The 30 meters again rock face is again 30 meters coal is again rock face is again 30 meters. Like that, number of patches of coal is available. So 30 meters is there. The 30 meters is converted into three vertical benches all over the area. The vertical benches are spread. Again rock face is removed. Again the 30 meters coal is there. The 30 meters coal is converted into different benches. It is there. So when the production is very much, when the coal production is very much more, suppose generally the smallest OC mine is 1 million ton. Generally up to 10 million tons. Generally there's a moderate mechanization up to 10 million tons we use. The more than 10 million tons, the heavy machinery, heavy mechanization is used. So 1 million ton to 10 million tons, 1 million to 10 million tons general. The moderate mines, the production of the moderate open cast mines. So suppose if the production is more than 10 million tons, then a heavy production is coming out of the coal plants, it is there, and in that the production is very much more, and the dumpers for the transporting the material from the mine point to the CSP, coal screening plant is there. The coal screening plant may be lying maybe 5 kilometers away from the OC point, OC mine, it is there. So the dumpers transport the material from the from the face point to the surface point, and from the surface point to the CSP, where the material is dumped at the coal screening plant. So there different impurities are taken out, and again the coal is shifted to the bunkers, and from bunkers the railway wagons are there, and the lorries are there, and the private companies take away the material from the bunkers. Suppose NTPC is there, so the coal is supplied to the NTPC by the railway wagons are there. So under the bunkers, the railway wagons are there. The wagons come under the bunkers, and they take the material from there. So this is the system of transporting the material, the coal material to the consumers. So small consumers they pick up the material by the plying of lorries. It is there. Suppose NTPC is there, steel plant is there. Suppose they take up the material by taking the assistance of the railways by the use of the railway wagons, and the railway wagons carry the material from the CSP, from coal screening plant to the NTPC, it is there. So heavy production is there. Then the shape of the and size of the approach road, it must be very much high, it is there. So the production decides the size of the approach road. And simultaneous of working on the phases. Naturally, when one phase is there, suppose in the 50 volts, suppose OB is there, and 50 tons of explosive used generally, and generally there also 1000 tons of the coal is the OB is created. In the similar plan, number of OB phases are there, number of coal phases are there. So when number of working phases are developed, suppose one phase is producing when 50 holes are used, suppose 10 meters, and the production may be this one maybe suppose 30 to 50 wells which are used, and the depth of the hole maybe 10 meters, and number of holes we use there, like that. Volume into density is the production. The volume is equal to L into B into H is the this one. Density is 1.5 or 1.4. It is the density, and burden into number of holes we use there. Burden into spacing into number of holes. Burden may be 1 meter, 1 meter into 1 meter into, and height may be the 10 meters. Height may be 10 meters, and number of holes may be the 50 meters into 1.5 is there. This much the tons we created. How it becomes automatically the 1,000 tons of the production is achieved in a from a single phase. It is a number of phases are there. Number of phases we use the number of phases, and maybe the OB phases, maybe the coal phases, all phases all together. More OB is created and more coal is created. So the blasted out coal, the blasted out rock waste has to be carried away, must be removed by the transporting machinery. It is there. So more number of phases means the more number of production, more number of rock waste, and that has to be created, and the heavy mechanization required, and the size of the approaches must be very bigger. It is there. And location of the crushing point. Suppose generally the crushing point, suppose the coal is there. Screening plant, generally crushing plant means coal screening plant. So the coal screening plant away from 5 kilometers. So a small, suppose a trucks and lorries cannot transport the material. Suppose a lorry is there, a 20 tons lorry is there, the lorry can transport only 20 tons up to the 5 kilometers and again. But so if we use the lorry and the transporting is insufficient and mismatch of machinery is there, so the system fails there, the OC fails there. So we use the high capacity dumpers. If the highly mechanized 285 tons dumpers, the single dumper carries away the material. 235 tons to 285 tons material is carried away from the mine site to the coal screening plant, from where the coal is distributed. So the location of screening plant just nearer 5 kilometers nearer to the this one. So if it is a big mine, and if it is a very small mine, and the crushing plant is very near, it is there. So if it is suppose 5 kilometers away, then heavy machinery use, heavy machinery decides the size of the approach road. The overall economy, when high mining projects, very and a very bigger open cast mining process we use there, and a bigger mechanization we use there, and high mechanization is used there. When high mechanization we use there, then the capital outlay generally is very much more, and the overall economy is very much more. And the economy, we invest the economy, the investment of the capital is very much more, and the outcome, the returns for the open cast is also very much more. The overall economy is also more. So one OMS it is generally 30 to 50. So one man produce the 50 tons of coal in a shift. It is called OMS. So it ranges from on the mechanized mine. The OC ranges from 30 to 50. So high production is there. It produces the high economy, and high economy is there when the money is coming a lot and lot. So with the money, with the seller of the money, so we will have a lot of money, and a lot of money which can be used for this one development of the approach road. So when the mine flourishes, in the profits, then some of the amount may be used for developing the approach road. So these are the different the factors which influence the factor which is the formation of the hard road. The surface topography is there, and the shape of the mine is there, and length of the mine along the strike direction is there, and the system of the waste disposal and the mineral handling, haulage gradient, and depth of the working is there, and the production is there, location of the coal screening plant, CSP is there, The family is working of a number of phases is there and overall economy. These are all. So the size of the approach road and the length of the approach road, the maintenance of the approach road is there with this thing is there. So this is about the approach road, the formation of the approach road, and maintenance of the approach road is also there. The maintenance, well maintenance, it must be there. A certain gradient must be there, and the lighting must be arranged. In the nights also, the temples are flying there, the lunar is flying there. So the lighting has to be arranged. Very good lighting has to be arranged, and a similar fashion, the signboards, whatever the curves are there, the signboards must be established, must be put there, and the suppose a heavy machinery is moving on the approach road, so a lot of dust is raised. So the water sprinklers we use there for the dust suppression and stuff. So the maintenance of the roadways, the maintenance of the approach roads also must be there. It is there. So this is about the approach formation of the approach road, the factors affecting the approach road, and the maintenance of the approach road. And next, coming to the transportation and the backfilling. Transportation, actually different phases are there. The drilling is there, the blasting is there, and the lifting is there, and the transportation. So these are the phases of the mining is there. The drilling is done by the coal drills or the OB drills, and after that the SMS plants, site mixer slurry plants, come over to the benches and charge all the blasting drill holes. So number of holes are there, 30 to 50 holes are drilled on the benches. All the 30 to 50 holes are charged by the ANFO material, ammonium nitrate, fuel oil mixture is the slurry we use in the open cast, we use in the mechanized open cast mining. So we charge all the holes with the ANFO material. So the blasting is done. So and the production is formed, production is created, and the mud pile is created by the blasting. So the shovels are the different excavators, the front end loaders are there, back end loaders are there, and hydraulic excavators are there, and the shovel excavators are there, and all the different types of shovels, the suitable shovels generally the hydraulic excavators use there, and different types of the shovels we use there, and those shovels will use for transferring the material from the face, from the bench point to the onto the dumpers, so the dumpers are there, the dumpers carry the material up onto the to the dumping yard and to the CSP point. Suppose dumping point is there, depending suppose dumping yard is there, the dumping yard actually the dumping yard is there and the CSP is there. Suppose a dumping yard is there, the dumping yard just closer to the mine, and they transport the material by this one and dumps over the OB material there. Suppose CSP is there, dumper carries away the material, from the mine point to the coal screen point. It is there, so the dumpers used there. So this is about the transportation with the help of dumpers, and different types of transportations are there. Simple mines are there, and the length is very, the transporting distance is very small. Then generally we use the rope haulages and the scrapper chains. The scrapper chains is run by the electricity, which drives the motor. Motor drives the chain. The chain with the flights moves, and the chains with the flight carries the material. So with a very shorter distance, we transport the material. 1.5 to 1.5 kilometers we use there. And rope haulage, generally rope haulage, maybe the direct rope haulage is there. So from the deposit point, the transport the material from bottom of mine point to the surface of the mine point, generally you use. So rope haulage using the open cast mine is outmoded, so we cannot use this one. And the excavations also, we cannot use there. Only lorries and the trucks we use for transporting the material from the mine site to this one. It is there. So the lorries and the trucks we use, very small quarries are there, and very small mechanized mines are there. So we use small this thing it is there. But if it is a mechanized mines generally transporting is generally done by the dumper truckers. So suppose sometimes we use high angle conveyors or this and belt conveyors also. But the depth of the mine is very much more, and the CVSP is very nearer than high angle conveyors we use there. Generally, it is up to 1.6 kilometers, and the high angle conveyors is there, and for use for transporting the material from the bottommost point to the under the surface. It is used. From the surface, the belt conveyors are there. The belt conveyors which is used up to 16 kilometers. Up to 16 kilometers, the belt conveyors can be laid out and transport the material from that one. From 16 kilometers all the way the 16 kilometers transport the material. It is there. So the belt conveyors are there. High angle conveyors which is used up to 1.6 kilometers from the mine point to the surface. It is there. High belt conveyors are there on the surface to CSP. The will transport the material up to 16 kilometers. We use there. When high mechanization there, high OB is there, high mineral is there, high coal is there, and this is then this type of transportation. This is about the transportation. And next one is the backfilling. Backfilling. Suppose the backfilling is the OB is there, and 50 meters of OB is the OB is even the coal is export. The particular OB is blasted out. OB is converted to different benches, and benches is removed. And after the coal is removed, actually again the void is created. The created void is filled up by the rock waste. Actually, the OB dumping yard is the dumpers we use there. The dumpers dump over the rock waste there, and we save the dumpers. We save the rock waste there. So when the void is when the total coal is excavated, so again the rock waste which is used for the backfilling. Before first the rock waste is used, the rock waste is and after that the soil which is saved, the earth which is excavated, the earth material is dumped over the rock waste. The first we use the rock waste, and after that the soil is used, and after that suppose the ash is available, the ash is used for filling the material, and after that subsoil is there. First rock waste is used, and after that soil is used, and after that ash is used, and after that subsoil is used. And this subsoil which is used for agriculture, which is used for farming, which is used for growing the vegetation we use. So this is the sequence we follow. This is the sequence we use in the OB material. Once again we will see the sequence of the rock face. The dumping yard is a dumping yard. The rock face is first filled up, and after that the earth which is excavated by the excavators is filled up by in the voids, and after that the ash is available. We ash is there, and we will get the ash from the NTPC, and the ash is filled up, and after that one, and after that the subsoil is which is saved there, and the subsoil is used for filling up the void. So this is the sequence: the rock waste, and the earth, and the soil, and the ash, and the subsoil. This is the sequence of filling the material in the void. It is there. It is there. So this is the sequence. So the subsoil which is very important. So all micronutrients, nitrogen, the zinc, and the phosphorus, the sodium, and the potassium. These are all called the micronutrients. The micronutrients are there in the subsoil. So while while going for the open cast mining, the subsoil is very much saved, and saved at a place. After filling up all the material, and over the material, the subsoil is finally is spreaded spreaded on the wash, spreaded on the soil, and the subsoil is where lot of lot of micronutrients which are there. So the micronutrients which are very much useful for the green vegetation. So the subsoil is saved, and the top layer is the subsoil, and for the growing vegetation, and the subsoil is on. So the paddy and the cotton, like that, crops may not be grown, but the paper, this one, paper industry, the eucalyptus, shubapal, nilagiri plants can be grown in this type of a land where the land is reclaimed. We call it as backfilling, also called the land reclamation. Reclaiming the, bringing back the land to the original shape is called land reclamation. Backfilling our land. Thank you.